Hey guys, good morning. It's me, Tristan, and this is my presentation on water gas shift reaction. Alrighty guys, so the type of reactions we're going to be encountering today are CO plus H2O equals CO2 plus H2, and the other one's going to be CO plus H2O equals H2 plus CO2. Alright, so first of all, y'all are probably thinking, what is water gas shift reaction? Like, what is that? Well, water gas shift reaction is an important reaction in adjusting H2CO ratio from chemicals producing or eliminating CO by transforming it into CO2 before the H2 and CO2 separation step. The water gas shift reaction is CO plus H2O equals CO2 plus H2. So the best environment for this reaction to encounter is it appears to be fast in alkalized iron catalysts, and also throughout the researches that I found, um, synthesis gas from high temperature or heavy oil gasification with CO content can directly be used for Fischer-Tropsch synthesis on iron. And in these researches that I'm going to be talking about shortly, they say that the reaction ceases to become more lively and increases production in higher temperatures. So, in my first research for my topic, I found that the role of the fuel in the operation and performance and degradation of fuel cells. In a recent study, they talk about what water shift to gas reaction is in their research, and it's done by an increase of H2 and the reduce of the CO content of the reformant. This is done by reacting CO present in the mixture with steam, such as the following moderately exothermic reaction takes place. In order for this reaction to occur, they had to heat the temperature up around 280 degrees Celsius, and the reaction they had used was CO plus H2O equals H2 plus CO2. So my second research, this will be talking about the syngas treatment and how raw syngas can be channeled to dedicated water gas shift reactor prior to the syngas cleaning, or it can be sent to the scrubbing system after being cooled down to 185 degrees Celsius. The water gas shift reactor can operate between 300 to 600 degrees Celsius and can facilitate either the forward water gas shift reaction or the reverse shift reaction. H2 and CO ratio above the recommended ratio allows the system to recycle and reuse more CO2 to shift the ratio to the desired value. And for my last research that I've done on this topic was the economical standpoint that it has. The water gas shift reaction can aid in the efficiency of fuel cells hydrogen production. The water gas shift reaction has played an important role in industrial chemistry, such as providing a source of H2 to feed a fundamental industrial transformation, companies such as Haber-Bosch synthesis of ammonia. The emergence of homogeneous catalysts in the 1970s marked the beginning of a synergy between water gas reaction and organic chemistry. So to conclude my PowerPoint, the summary that we learned about water gas shift reaction is that it's basically just adjusting the H2CO ratio for chemical producing or eliminating CO by transforming it into CO2 for the H2 and CO2 separate. And lastly, like what we last learned about was seeing the importance of water gas shift reaction and how it stands economically in our system and how important it is to us and how we can gain jobs for in the chemistry field, and how it's creating catalyst and how it reacts with catalyst, and we can find more data based on that.
Thank you.